Hello.
There we go.
Okay. So question number 3. What requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Mark all that apply. Let me get my notes on that. Hold on.
I think it's number 1. A simple random sample is drawn from each population.
But is it more than just one of them?
I think there's 2 of them.
Oh, normally distributed, yeah. I think 1 and 2 then. Is there more than 2?
No, I think there's just 2, and I
That's,
think it's right.
yeah.
Okay, that's what I thought.
Okay. Number 4. The test statistic for a hypothesis test comparing two means with independent samples is a t-score.
T like Thomas.
Thomas the Train.
Yeah.
Nice.
Are we going to get into something called an F-score? Because that would be fun. Not an F statistic, but an F-score. Because I think I've gotten that before.
Fun. I agree. That'd be the fun score.
A fun score.
Yeah, we like fun. Question number 5. 2 samples are independent if knowing which subjects will be in group 1 determines which subjects will be in group 2, or knowing which subjects will be in group 1 tells you nothing about which subjects will be in group number 2, and it is the last or the second one. Good job. I got one right, guys.
Like what is that? Is that part about being paired or whatever it is?
Yeah.
So they're paired, but they're not dependent or whatever.
Yeah, so they're independent because they don't. The people in group 1 aren't the same people in group 2.
Okay, right. I'm with you. Oh, here we go.
Are we on question 6? Yep. Okay. For the next 6 questions, use the data file dentist office bills. This data represents a simple random sample of dental bills at a dentist's office in Idaho Falls and a dentist's office in Rexburg. Let mu1 be the mean bill at the Idaho Falls office and mu2 be the mean bill of the Rexburg office. Perform a hypothesis test to determine if the mean bill at Idaho Falls office is less than the mean bill at the Rexburg office, which means we have the null hypothesis equals to mu1 equals mu2, and alternative hypothesis is mu1 is less than mu2. Use the level of significance of 0.10. What is the degrees of freedom? Round to the 3 decimal places. So does everybody know how to figure it all out?
Ish.
Okay. I wish that they would put the SPSS like at a different place, like all the ones that you need, like in the group meeting one.
Yeah.
Then I'm scared to open my quiz again in this other section. But I'm gonna try it.
Okay, so is this where we have to start recoding right now?
Yeah.
So we're recoding, and we recode for the bill, the dentist bill.
Yes. Well, no, we're not going to recode for the bill. We're going to recode for the cities.
We're gonna recode for the cities. Okay, so let me try this again. City. Okay.
So I have everything filled out, but then I can't remember if I want to add to template form or save template as.
What part are you at?
Thank you. I'll get it. So I'm at the automatic recode. I put the city over to the variable. I made a new name.
Okay.
Then I put lowest value.
You just hit add new name and then you hit OK. You don't have to add template from or save template as. You don't have to do that.
Okay.
You just hit OK.
Okay, thank you.
Okay, now what am I doing with that next thing then? Miranda, you gotta tell me. So I got the auto recode variables, and then what's the button I'm supposed to push now?
So now we're due analyze, and we go to compare means, and then we do the independent samples t-test.
Okay, thank you. I couldn't remember where I had to go for that.
Yeah.
So, and then test variable is recode. What's the grouping variable? Is the dentist bill?
The grouping is the city. And then you have to define the groups.
And this one we put Idaho Falls and Expert, right?
Yes. So no, we just put 1 and 2. So Idaho Falls should be listed as 1 already.
Okay,
So you put group 1 is 1 and group 2 is 2.
perfect. Okay, thank you.
Yeah.
I'm not sure what I did wrong. Mine says string variables are not allowed in the list.
Did you put a space bar in the names?
Mm-mm.
Okay.
I didn't do anything to the names.
Okay. I don't know what that is then.
I'll try. Okay, let me start again.
So was your test variable recode when you're doing your t-test?
What? Sorry.
So independent sample t-test. Did you put was the test variable the recode?
Oh, yeah. So the city code, or it's the one that we did again?
So your recode is the test variable. That's what I'm putting in. And your grouping variable is just the city code, the original city.
No, let me get back into it. Hang on. Okay, so the test variable is going to be, let's see, where is it? Sorry. Test variable is the dentist bill.
Okay. And then the recode is the grouping variable.
The recode is the new one that you said, the city and code, whatever you renamed it.
Yes.
And then you'd say define groups, and group 1 is 1, and group 2 is 2.
Okay, I got it.
And then
I'm
you
going to
hit
use
OK.
this every day for the rest of my life when I'm done with this class. Every day.
Well, you probably only bought a 6-month subscription, so you're probably going to use
No.
it for 6 months.
I'm buying the whole thing. Okay.
Oh, yay! Thank you, Miranda.
Yeah. I don't know what I did, but you're welcome.
I explained it well enough for me to
Just
understand.
putting the right thing in the right place to make it work.
Perfect.
Okay, so do we all got that now? Number 6, degrees of freedom. That's the DF. So 37.996.
Yep, that's what I got.
Okay. Number 7, sample standard deviation. So that one goes to standard deviation in the group statistics for Rexburg 206.637. Everybody think that's right?
Wait, hang on. Number what? 7?
Number 7, standard deviation for Rexburg.
And you said which one? What did you say?
206.637.
Yes, that's what I got.
Okay. Gabby, you got that same screen in front of you?
No, I'm just a little bit behind you guys.
We'll slow down. We can wait.
I just feel bad. I just was talking about how it's not a big
It's
deal
okay.
that mine's slower.
It's okay, Gabby. We want you to make sure. We want to make sure that you know what you're doing too. Like, we don't want to just skip ahead for you. It's not fun.
Okay, I'm still getting the bad code, and I don't know why.
So the bad code, does it come up like warning this is wrong type thing?
Okay, so it will let me put in, and maybe this is what you guys were talking about when I was trying to figure it out and I zoned out a little bit. But the test variable, it will only allow me to do the dentist bill.
Are you
And
automatic? Are you doing the automatic recode right now?
I'm doing
What part are you on?
the independent sample t-test part.
Okay, so you've already done the automatic recode.
Yes.
Okay, so you're going to analyze, compare means, independent sample mean test. And so yeah, the test variable is going to be
The dentist bill.
the dentist bill.
And then I do the new name for the grouping variable.
Yep, and then you're going to hit define groups.
And it won't let me. I don't know why. Oh, there it goes. Okay, nope, I got it.
And then group 1 is 1 and group 2 is 2.
And then okay. Okay. Now I think I'm up to speed. And you guys got, for the first one.
Sorry, you cut out.
So for number 6, what is the degrees of freedom? This is a pain in the butt. Okay. I have 37966 or 3996.
Say
You
it one
got
more
it.
3.7996.
No,
Yes, that was for number 6.
no. 37.996.
Yeah, that's what
Yes.
I got.
Perfect.
Yep.
Okay. And then we just list what's for Rexburg and everything else as it's seen.
Yeah, so for number 7, we got the 206.637. Are we ready for number 8 then?
Yes.
Yes.
Okay. I put negative 0.434 as the test statistic.
I put 2.
Sorry, what answer was, or what did you get for the answer again? I was just
Negative.
pulling it up.
Negative 0.434.
Yes, that's what I got as well.
I can read graphs, guys.
Okay, number 9 is confusing to me. Is that our sig? Is that the t?
Yes.
The the p-value?
Yes.
And is this a two-tailed test? Because I thought
It is a two-tailed test because the, oh no, never mind, it's not.
because
You're right, Jeremy.
it says less than, right?
Yeah, so
So then
it's
what does that
actually-
become then?
so it's actually not negative 0.434. We actually have to divide that answer,
By 2.
divide it by 2, and so we get the answer of the real answer, which is,
Wait, do we have to divide the test statistic by 2 or the p-value by 2?
I thought it was the
the
sig.
p-value. Oh, yeah, sorry, I totally, what,
For number 9?
0.666 divided by 2, right?
yeah, I just hit number 8. I scrolled up and then I scrolled down to number 8, but I wanted number 9.
So you're okay with number 8 still, but number 9, is that going to be 0.333?
Yeah.
It should be.
That would
Because
make
it's one-tailed because it's less than.
0.4135 by 2. No, it's going to be 0.207 because you do
Oh, yeah.
0.413 divided by 2, which gives you 0.207.
Hold on. I'm confused by that.
Me too.
So the zig score is the piece
Oh.
value.
Sorry. I'm
No,
just
you're-
really confused today.
No, you're good.
So the zig score is the p-value, and
Okay.
that's what they're wondering. But the zig score is 0.825.
So I have the zig score as 0.666, the double
That's
number.
what I have too. No?
So my zig score is 0.825.
Oh, so what we're seeing here is that the zig score is 0.825, but we're looking at the
We're looking at the two-tailed.
What's the difference?
Oh, I see your two-tailed. Yeah, it is going to be the two-tailed, I think.
So it is
I don't know which
0.333? Or I don't know how many times I said 3 there.
Let's just do the 333 because I think that's probably what it's going to be.
I don't know what that first one is. The quality of variances test.
Yeah, I don't know what that SIG is either. I totally forgot we were supposed to go from the SIG two-tailed. So, yes.
So we're going 333, I think.
Yes.
And our level of significance, 0.1, and we are 0.333. So because we're higher, we have to fail to reject.
Yes.
I like that answer. Yep.
We all concur. Good. Woo-hoo.
And we're already over halfway through this test, guys. Good job.
Woo.
Hallelujah.
Let's not let it be 11 o'clock again.
So,
Thank you.
So suppose instead that you had used the alternative hypothesis of mu is not equal to mu2. What is the correct decision based on this evidence?
so we failed to reject it.
Correct, but this is a different equation.
So it doesn't matter what the last one was. Okay. So
So basically,
no, it's just the alternative hypothesis. The original
it's
hypothesis
just
still is.
changed.
So then
We wouldn't have enough.
we still have insufficient evidence.
That the mean
Yes.
density bills between the two cities are different?
Yes.
Okay.
Okay. Freshman dinner.
Okay, I'll read. For the next 6 questions, use the data freshman dinner. This data represents the number of times freshman students from Utah and Colorado cook their own dinner in a month. Let mu1 represent the mean number of times a month that a student from Colorado cooks dinner, and let mu2 represent the mean for Utah students. You suspect the freshmen from Utah cook dinner for themselves a different number of times than freshmen from Colorado. Perform a hypothesis test to determine if your suspicion is correct. The null hypothesis is HO by mu1 equals mu2. Use a level of significance of alpha equals 0.05.
So question number 12 is the second option because they're asking.
That's the opposite or the alternative.
Okay, could someone walk through how to do the... I'm just worried that I don't know the steps exactly of how to do the SPSS thing.
Yeah. Let me get back in here.
So we're doing the automatic recode again, right?
Yep.
Yes. Oh my gosh. Oh, okay.
And we're going to recode the
State.
city. Well, state. Yeah. State
Oh,
code.
I think I did it on my first try.
Nice.
Okay, then we're going to analyze, and we're doing the independent, or compare means in the independent sample test, correct?
Yes.
Yes.
Okay. The test variables should be freshmen, correct?
Yes.
I thought we
Yes.
were doing it by the different states. No?
Test variable is going to be the freshman. The grouping variable is going to be the state.
Okay.
The
Because we
recoded.
recoded the state. So whatever we recode, that's going to be the group.
Okay.
Does that make sense?
Yes.
Okay.
So I sort of got it right, right?
I think you got it right, sort of, but yes, not just sort of, but yes.
Oh, okay. So for I cannot say that word today.
You know, statistic is a hard word to say, especially if you've said it a million times.
It's just rough. So we have 0.867, is that, or negative 0.867?
Nope, because you want to do the bottom line.
How do we know if we want the bottom one or the top one? Because I got both those answers.
From what I've heard is we're just going to always use the bottom one.
Okay, I like that kind of a rule.
Okay, me too.
Negative
Thank you.
0.845. P-value, then that is bottom one, sig two-tailed, yes? 0.410.
Yep. And number 12, we did the middle one, right? Which is not equal to?
Yes.
Okay, yeah. So yeah, it would be 0.410.
Okay, so 0.410, because our level of significance was 0.05, we are going to fail to reject because it's bigger. The p-value is bigger than the null.
Yep, you got it.
I mean, not the null, the level of significance.
Yes,
Fail to reject. Okay,
got it.
3 more.
Yep.
Okay, so for this one, now, do we take the upper on that lower, so the whole lower line, we take the upper variance, 95 confidence interval, minus the lower 95% confidence interval of the difference, and that's our answer? Or do we have to divide that?
For the margin of error?
Yeah.
Oh.
I think I remember you have to take the upper minus the lower, and then you have to divide it by 2 or sample. I can't remember.
Wasn't it times by 2?
I don't remember because what I have for the margin of error is 2 times the standard deviation divided by the square root of
That's
n.
what I have too.
And so, but when I did that once, I got the wrong answer, so I was really confused. So what I've been doing, let's see. I've been doing it the hard way, but I didn't care.
I don't know.
So 1 point.
Really fast. I just want to make sure that I'm doing the p-value right because I kind of missed what you guys are saying in there. So I'm going to divide the bottom number, right? The two-tailed? Or is it just the two-tailed for 0.410?
So because it's asking if it's not equal, it's a two-tailed score. If it's asking if it's higher,
Okay.
then it's half of that. If it's lower, it's half of that.
You, Emma.
You're welcome. That's one I can answer.
Good job, Emma. You are doing awesome.
This was not terrible for me, I won't lie.
I don't know. I know we have to mess with the upper and the lower, but I can't remember if there's another step to it besides just subtracting them.
Yeah, hang on. Oh, do you know what?
So Google has an answer of how to find the margin of error. Would you like me to read that out loud?
Sure.
Okay. So it says find the sample size n and the sample proportion. Multiply the sample proportion by, divide the results by n, and take the square root of the calculated value. I have no idea what that's asking.
Never read that to me again.
Okay.
Oh.
Okay. Hang on, I'm almost
You're
trying to figure
fine.
this out.
Yeah, we definitely have to do something with it because.
Okay. I figured it out.
What did you figure out?
The margin of error. Okay.
Yeah. How?
So this is how I'm doing it. I'm doing it probably so backwards and so much harder, but this is how I'm doing it. So we have our 95% confidence interval. We know what that is. It's negative 5.13734. It's the lower one. The upper is 2.20401. Okay. So we know for sure, we know the formula of how to get the confidence interval, which is the mu minus the margin of error will get you the lower one. The mu plus the margin of error will get you the upper one. So basically I'm doing the math backwards. We already know what the lower one is. We know what the mu is, but we don't know what the margin of error is. So I got the mean difference, that's the mu, is the negative 1.46667. Is everybody following me there?
Hold on. The 1.4. Okay, yes.
Okay, so that is going to be in the very beginning. And then we're going to minus the margin of error, so minus m, and then we're going to equals the negative 5.13734. So I did my algebra or whatever, and since it's a negative, I plus it, and then I do it all, and I get the answer of 3.67068. And I did it for both the lower and the upper, and I get the same answer.
Okay,
Awesome.
let me tell you how I did this, okay?
Okay.
I took the upper 2.20401, subtract the lower minus 5.13734, and I got 7 point whatever, and then I just divided that number by 2. Bingo, bango, bongo.
And you
Wait,
get
how did you do it?
0.67.
Upper minus lower divided by 2. Same answer.
The very, very upper, the 2.06.
No. Upper
Sorry.
2, all on the bottom line. I haven't used anything off the top line.
Okay, I thought you said that for some reason. So the 2.204,
01, yeah.
and then, okay, so upper minus
Okay.
the lower
Minus 5.13734
divided by 2.
divided by 2.
Awesome.
3.670675.
So I've got 3.671, right? Is
Hey,
rounded.
you did it a way that
Just-
I think makes a lot of you understand the concept better.
It's on the back. It's the backwards though. Like I definitely did more work than you did.
You deserve more points then. Make a note of that, professor. Make a note of that, teacher. You should give Miranda more points.
No, I'm.
Well, sometimes you can't
Upper.
remember tricks, but you can remember if you understand the concepts and the formulas and stuff. So
Awesome.
So could someone repeat the final answer?
3.671.
yes, ma'am.
Thank you.
Yes.
So the lower and the upper are right on there.
That is awesome. I like when it's a little bit easy.
So, yeah.
Thanks,
I
guys.
just submitted my quiz.
Did you submit?
I'm about to. I'm just coming up with the answer right now.
Oh, I'm submitting too. Should I not?
Looks like we missed half of a point.
Where'd you miss half a
What
point? Which
question?
one?
I'm looking for it. Hold on.
Only the last ones are worth half a point, I think. 17 and 18.
I got 100%.
Okay, so I missed the 17. I must have written it down wrong.
Did you do negative?
No, that's where I got it wrong.
Yay, you can fix that.
Yay! Good job, guys.
We did good. Good job.
That
And
was
it's not
great.
even 10 yet.
It's not even 10. That makes me
Awesome.
so excited.
I'm tapped